In this lesson, you will learn about high availability, HA, and the different ways you can achieve HA on FortiSOAR. In this lesson, you will learn about the topics shown on this slide. After completing this section, you should be able to achieve the objectives shown on this slide. By demonstrating a competent understanding of HA, you'll be able to use different methods to achieve HA clustering with FortiSOAR. There are multiple ways you can implement HA for FortiSOAR. You can create nightly database backups and incremental VM snapshots. FortiSOAR provides backup scripts that are scheduled to run at predefined intervals and make full database backups on a shared or backed up drive. You must supplement the full backups with incremental VM snapshots whenever there are changes made to the file system, such as connector installation changes, configuration file changes, upgrades, schedule changes, and so on. You can also achieve high availability using your virtualization platform, such as VMware HA and AWS EBS snapshots. This method relies on your expertise and infrastructure. You can configure an external Postgresql database and use your own database HA solution. You must take VM snapshots whenever there are changes to the file system, such as connector installation changes, configuration file changes, upgrades, schedule changes, and so on. FortiSOAR provides a native clustering solution as well. You can configure more than one FortiSOAR node joined to form an HA cluster. When you deploy a FortiSOAR instance using the FortiSOAR configuration wizard, the instance is a single node cluster with the single FortiSOAR acting as the active primary node. You can join more nodes to this node to form a multi-node cluster. FortiSOAR HA uses PostgreSQL database clustering. It supports active-active and active-passive configurations with both internal and external PostgreSQL databases. You can deploy HA clusters to fulfill one of two possible use cases: disaster recovery, DR, or scaling. For DR, you can configure an active-passive cluster that has the passive node located in a remote data center. For scaling workflow execution across multiple nodes, you can use collocated active-active cluster nodes. Good job! You now understand HA overview. Now you will learn how to configure HA on FortiSOAR. After completing this section, you should be able to achieve the objectives shown on this slide. By demonstrating competence in configuring HA, you will be able to configure FortiSOAR HA cluster using an internal or external PostgreSQL database. You should verify a few prerequisites before configuring your FortiSOAR HA cluster. The FortiSOAR nodes must be on 5.0 or later. Update FortiSOAR if it is running an earlier version of firmware. You should be able to resolve all cluster nodes in DNS. You must configure the FortiSOAR HA cluster using the CLI. You must also ensure that your SSH does not time out. You can increase the session timeout value in your SSH application, or use the screen command to ensure that the SSH session does not time out. Refer to the knowledge base article shown on this slide for more details. If you have an external firewall or any other security policies between the HA nodes, then you must ensure that the following ports are open between the HA nodes: 5432 for PostgreSQL, 6379 for Redis, and 9200 for Elasticsearch. It is highly recommended to install the cluster behind a load balancer so that the cluster address remains unchanged regardless of which node is the primary. You can perform a fire drill on a secondary, active, or passive node only. Running the fire drill suspends the replication to the node database and sets it up as a standalone node pointing to its local database. Since the fire drill is primarily performed to ensure that the database replication is set up correctly, it is not applicable when the database is externalized. After you have completed the fire drill, ensure that you perform a restore to get the nodes back to replication mode. The table on this slide lists all the subcommands that you can use with the csadm-ha command. You can use the csadm-ha command to perform various cluster operations. The get replication status command displays the replication delay and status between cluster nodes. For the primary node, this command displays the replication statistics. Running the fire drill suspends the replication to the node database, and it sets up as a standalone node, pointing to its local database. Because the fire drill is performed primarily to ensure that the database replication is set up correctly, it is not applicable when the database is externalized. After you complete the fire drill, ensure that you perform a restore to get the nodes back to replication mode. Good job! You now understand HA configuration. Now, you will learn how to externalize the PostgreSQL database. After completing this section, you should be able to achieve the objectives shown on this slide. By demonstrating competence in externalizing the FortiSOAR PostgreSQL database, you will be able to migrate data from your local database to a remote one. Externalization is migration of data from your local database instance to a remote database instance that has the same version of PostgreSQL outside of the FortiSOAR VM. To externalize your FortiSOAR PostgreSQL database, you must have root access on FortiSOAR, and you must use the FortiSOAR admin CLI, CSADM. First, you should prepare your remote instance. The remote instance must allow inbound communication from your FortiSOAR local VM and have PostgreSQL version 12 running. Then, you should prepare your local FortiSOAR instance. Ensure that port 5432 is open for PostgreSQL to allow inbound and outbound communication with the remote instance. Ensure that the connectivity between your FortiSOAR local instance and remote PostgreSQL instance is established. If the FortiSOAR instance was connected previously to the same instance of the database that is being externalized, it could lead to a stale connection being presented to the FortiSOAR database on the external Postgre server. To solve this issue and release all stale connections, restart the Postgres service using the command shown on this slide. Ensure that you have stopped all your schedules and that you have no playbooks in the running state. You must also ensure that you have enough disk space available to perform database externalization tasks. It is recommended that you have at least 3 times the data size you are transferring in available disk space. For example, if your data size is 2 gigabytes, then you should have around 6 gigabytes of available disk space to ensure that the processes do not stop or fail. Good job! You now understand how to externalize the PostgreSQL database. Now, you will learn about HA best practices and cluster monitoring. After completing this section, you should be able to achieve the objectives shown on this slide. By demonstrating competence in applying best practices, you will be able to configure and manage HA clusters effectively. You might want to increase the wall_keep_segments. The PostgreSQL.conf file has 2 settings that you can configure to fine-tune a FortiSOAR HA cluster. max_wall_senders, which defines the maximum number of wall sender processes. By default, this is set as 10. Wall_keep_segments, which defines the log file segment size. By default, this is set as 5 gigabytes. Note that the max_wall_senders and wall_keep_segments attributes are applicable when the database is internal. Every secondary node needs one wall sender process on the primary node, which means that with the default value, you can configure a maximum of 10 secondary nodes. If you have more than 10 secondary nodes, then you must edit the max_wall_senders attribute in the postgresql.conf file on the primary node and restart the PostgreSQL server. By default, the wall_keep_segments attribute has been set to 320, which means that the secondary nodes can lag behind by a maximum of 5 gigabytes. If the lag is more than 5 gigabytes, then replication will not work properly, and you must reconfigure the secondary node by running the join cluster command. Note that if you make any setting changes in any configuration file on an instance, such as changing the log level and so on, it applies only to that instance. Therefore, if you must apply the changed setting to all the nodes, you have to make those changes across all the cluster nodes manually. Good job! You now understand HA best practices and how to set up cluster monitoring on FortiSOAR HA. Now, you will learn about troubleshooting different HA issues. After completing this section, you should be able to achieve the objectives shown on this slide. By demonstrating competence in using troubleshooting techniques, you will be able to address HA issues. You might receive a notification indicating this slide shows the after you restart the PostgreSQL service on the secondary passive node, you can see that the total lag. This slide shows the You might receive a notification indicating that there is a higher time lapsed from the last sync when compared to the general time lapsed. In this case, when you run the csadm HA get replication stat command on the secondary node, you might get a time elapsed from last sync value is higher than usual message. This might indicate that PostgreSQL is down on the primary server. There is no activity on the primary server. The secondary node is out of sync with the primary node. To resolve this, do the following. Run the systemctl status PostgreSQL-12 command and ensure that you are not getting the fatal could not receive data from wall stream. Requested wall segment has already been removed message. Run the csadm HA get replication stat command and check its results. A. If you get the value of sending lag is higher than usual on primary when checked message, it means that there is load on the primary node. Run the top command to check which process is taking more CPU time. B. If you get the value of replaying lag is higher than usual on primary when checked message, it means that there is load on the secondary node. Run the top command to check which process is taking more CPU time. Congratulations! You have completed this lesson. Now, you will review the objectives that you covered in this lesson. This slide shows the objectives that you covered in this lesson. By mastering the objectives covered in this lesson, you learned how to configure, manage, and troubleshoot HA cluster issues on FortiSOAR. You also learned how to manage cluster licensing and externalize the FortiSOAR PostgreSQL database.